First speaker this afternoon is Francesco Cubata. Dr. Cubata is a research scientist and team leader at the Italian National Institute of Health. The group he leads is primarily responsible for dietary exposure data, including total diet studies and duplicate diet studies, biomarkers of intake status, and biomarkers of exposure and human biomonitoring. He has over 150 papers to his name. And his presentation today will be the Italian National TDS, Intake of Nutrients and Exposure to Contaminants in the Italian Population. Dr. Cubata.
Thank you very much for this presentation, Mr. Chairman, and I'm glad to be here with you, although virtually. I hope you can hear me correctly. And today I will present you the design and some results of the Italian National Total Diet Study. I will start my presentation by showing some elements of the study design, and then I'll show some examples of the results obtained, just to briefly discuss a few specific points. And finally, I will highlight some take-home messages. So let's start with the design. We all know that there are two extremes in the design of Total Diet Study. One is a screening approach, where a few food groups are targeted. On the other hand, the other side of the range is a refined approach, where hundreds of food groups may be covered. For the Italian TDS, we decided to choose an intermediate approach. So we tailored to specific exposure assessment needs our design, which resulted in selecting a food list of 51 food groups, which was found to be optimal for the structure of the Italian reference diet. And we also tackled the four main Italian geographical areas, meaning that the samples representative of the food groups for these four main areas were not pooled, and 204 final analytical samples were studied for the different substances that were targeted. So just to have a snapshot of what the TDS was about in terms of coverage, we investigated 65 substances, covered four main geographical areas, as I said, 51 food groups, more than 3,000 elementary food samples were collected, which led to an estimated number of analytical readings of about 23,000, and these resulted in some dozen thousands of individual exposure data, which were then examined in order to make conclusions about potential risks for human health. Another element that was considered in the study design phase was related to the extent by which the available food consumption data enabled to estimate the usual daily intake. We do know that data collected with 24 hours dietary recall or dietary records cover food consumption over a limited time frame, and especially when single measurements per subject are collected. And we do know that there are limitations of the use of these short-term food consumption instruments to estimate the usual intake, because we know that individual diets can vary greatly from one day to another day. So measurements in takes over a limited number of days incorporate considerable within person variability, making them a poor estimate of usual intake. So, to address this issue, statistical modeling may be used. In the case of the Italian data, since the reference study was based on 3 days individual dietary records, we decided to use these data as they were to make intake estimates. And of course, this led to some potential overestimation, especially of higher percentiles of exposure. For nutrients, we selected the AR cut point method in order to estimate the proportion of individuals whose intakes were not meeting their requirements. This method has some conditions for validity, meaning intakes and requirements for the nutrient must be independent. Distribution of requirements must be approximately symmetric around the AR, which is the mean, and also the variance of the distribution of requirements should be smaller than the variance of usual intake distributions. These conditions were overall met for most nutrients, not for all, but for consistency we decided to use this method at least as a first screening method to evaluate the adequacy from the nutritional point of view in terms of requirements. As far as contaminants were concerned, the individual intake was compared with the health-based guidance values available to establish the percentage of the sample exceeding them. So this is a snapshot of the reference data we used for the dietary reference values, the EFSA dietary reference values. The average requirement is the level of nutrient intake that is enough for half of the people in a healthy group, given a normal distribution of requirements, and this was used, as I said, to calculate the proportion of individuals having an intake above or below the requirement. Mean intake values were compared with a population reference intake, and when this was not available, with the adequate intake, which is estimated in place of the PRI when the PRI cannot be estimated because an AR cannot be set. For excess exposure to nutrients, we considered the EFSA tolerable upper intake levels, and for contaminants, we refer to the EFSA health-based guidance values, so typically tolerable daily or weekly intakes, and when a threshold could not be identified, the benchmark dose lower bound level was considered, and in this case, when no threshold is identified, the BMDL cannot be translated into a TDI or a TWI. So in this case, the BMDL was divided to with the exposure to estimate a margin of exposure, and as we all know, a higher margin of exposure indicates that there is a larger buffer for covering between a potential health effect and exposure to the specific contaminants. So this is these are some of the elements, the main elements, I would say, that we considered in the design of the Italian total diet study. First of all, we have to establish the TDS list and the level of pooling. This is a critical decision, as we all know. So we base this decision on the reference diet we considered. on the selection of the target population groups, and we then characterized the level of pooling. From there, we derived a TDS, final TDS food list. The sampling plan, we addressed geographical variability, as I said. We addressed seasonality, meaning that we identified the number of core foods that were to be sampled in different seasons. Then we characterized the TDS food shopping list, meaning we identified the individual foods to be sampled, and we also make choices in order to achieve representativeness by appropriate selection of the sample collection premises. Then we also elaborated about food collection and transport and kitchen preparation, and finally about chemical analysis, focusing especially on sample preparation for chemical analysis and on the performance criteria for analytical methods and analytical quality assurance. So this is a graphical representation of the way we proceeded from the TDS food list based on individual food consumption data to the food shopping list to obtaining the occurrence data, which were then combined with consumption data to obtain a distribution of intake data by gender, age group, and geographical area, and finally to perform the risk characterization, taking into account the reference values which I mentioned. The reference diet was based on the study on the individual food consumption survey of a few years in advance. Now this reference diet is being done in Italy. The survey is almost completed, so we should have the new data for both adults and children in a few months. We also make decision about the different age groups that could be covered. We covered, of course, the two genders separately, and we were able to cover children, teenagers, adults, and elderly people. The reference diet, unfortunately, covered not to a great extent infants and toddlers, so we make some intake estimates for this latter age group, but overall we consider them as merely indicative and tentative. So this is the TDS food list, just to give you an idea of the level of detail. And you can see that, for instance, influential food for dietary intake in Italy, such as bread or pasta or biscuits, etc., were kept separate. So, as I said, this was meant to be a good choice in terms of properly covering the entire diet by keeping separate important influential dietary items or items which might be linked to specific contamination issues. These are the four main geographical areas we targeted. So we had food consumption data for these main geographical areas, and occurrence data were combined with consumption data of refer to the same geographical area. Of course, we had to make also a choice in terms of where to sample our food. So we focused on four main cities where the sampling was performed, and this was meant to be a choice which was the best one, considered the budget issues on the one hand, but also the interest to at least to some extent investigate geographical viability. So we translated this food list into a food shopping list. So we had to gather information sources to identify the specific products to be sampled, and for individual food, we had quite some details in the annex of the National Food Consumption Survey, so we considered them closely. We identified species, variety, and origin of available national statistics to identify the data, the types of fresh food to be sampled, whereas for packaged food, we considered formulation, types of processing, and market share data. We identified specific retail outlets for each core food according to consumer habits. We covered hyper and supermarket from different distribution centers in order to reflect the structure of food retail in Italy. And tap water was, of course, the only food that was not bought. So a number of samples were collected at different sites in each location to have a meaningful representation of the local levels of this food. Overall, as I said, we sampled more than 3,000 individual products. Elementary samples were pooled into almost 1,000 individual samples, and this led to 204 final analytical samples for each substance, and the relative proportion of each individual sample within the pooled sample reflected the importance in the average Italian diet. As far as kitchen preparation is concerned, cooking was performed according to standard recipes for each geographic area. We consider carefully the issue of boiling food. This is important because influential food items such as pasta in Italy are boiled. So, for instance, salt was added to the boiling water in standardized conditions, and this was in order to closely simulate actual household conditions, and also considering aspects such as osmotic pressure, minimization of the loss of analytes into cooking water, and the intention to capture full exposure. After cooking, samples were pooled into individual foods and finally pooled into the 51 core foods according to the proportion of the average diet. Great deal of attention was devoted to performance criteria of the analytical methods and to analytical quality assurance. We had a very strict quality control program, including internal quality control, and you see an example of the certified reference materials that were used for a specific class of substances. Overall, we used more than 20 different certified reference materials to cover all the individual matrices, and also external quality control, meaning successful participation to proficiency tests. All analytical methods were validated for the specific food matrices that were studied, and a scrutiny was performed of the limits of detection and limits of quantification in order to reduce the uncertainty deriving from left sensor data. Overall, left sensor data were negligible for all substances studied in terms of their proportion, with the partial exception of a few mycotoxins. And this is the list of the substances which were covered. we have 8 essential elements, 9 non-essential elements, 45 dioxins and PCBs, 9 mycotoxins, and 4 radionuclides. Overall, 65 substances were covered, as I said. So just some examples of the results obtained, just to discuss with you a bit more about specific aspects which might be of general interest. These were the results for calcium. The structure of these results I will show you will be the same for the different substances. So you will see the intake on the top left. The mean intake is in blue, and the 50th percentile is in red. You see the dietary reference values on top right. Then there is a comparison with TDS, the French TDS of the time, which was considered as a useful reference because the design was relatively similar. On the bottom, on the left, you see the estimated proportion for nutrients. It is mainly of inadequacy, or when there is upper level also of excess. And finally, on the bottom right, you see the most influential food categories. So these are not the 51 individual products, but the 13 food categories to which the 51 core foods belong to. So in the case of calcium, we, for instance, see that there is a significant proportion of adolescents which is not meeting their requirements, which is, of course, indicative of the fact that requirements at the critical age are very high, but also the fact that indeed the diet was provided for these food groups, for this age group, calcium to a limited extent for a proportion of the subjects. Milk and milk products were the most important source as expected, but you see that in the Italian diets also cereals and cereal products and vegetables plays a role. These are the same figures for iron. In this case, we have higher requirements for women, so we estimated the ratio females to males for the estimated prevalence of inadequacy, and as expected, this ratio is going to be higher, much higher for women after adolescence. And we also see that cereals and cereals products are quite an important source in the Italian diet, followed by vegetables for iron supply, whereas meat and meat products is along with fish covering almost a fifth of the overall intake. So overall, a fifth of the intake is provided by sources which also deliver heme iron, in addition to inorganic iron. In the case of zinc, we also have an upper level to be considered, so we also performed an estimation of the proportion of the population which might have exceeded this upper level, and you see that quite a proportion of children actually exceeds this upper level. It was subject to further investigation. And on the other hand, as far as requirements are concerned, quite a proportion of adults and especially elderly people are not meeting their requirements. And the most influential foods for zinc intake are meat and meat products in the Italian diet, followed by cereals and cereal products, and milk products. These are similar figures for copper. For copper also we have to deal with an upper level in addition to um, to the other data reference values, and we see there is a small proportion of excess copper intake in children. And the most influential food category is cereal and cereal products. Finally, these are the data for selenium. These are interesting because these data were important also in the recent EFSA work for re-establishing an upper level for selenium. Data indicated that there was a proportion of children with relatively high intakes, and this was considered. There were actually only two total diet studies in Europe providing adequate data for assessing the intake in children, and these were considered by EFSA. And currently, this opinion on the new upper level for selenium is under public consultation, so it should be finalized soon, meaning that the upper levels you see on the top right will be not longer valid, and the new ones will come in place of them. Interestingly, for selenium, we have quite some food categories which are important in the Italian diet. We have cereals and cereal products, we have fish and seafood, we have meat and meat products, vegetables, and milk products. So this is a notable difference compared to the other nutrients we discussed so far. A few examples of contaminants, again with the idea of highlighting specific points. These are the data for aluminium. You see that there is quite a proportion of children and to a minor extent adolescents which are exceeding the TWI, which is of course of concern. We do know that aluminium exposure is largely mediated also from release from food contact materials. In terms of food categories, vegetables were the most important one in the Italian diet, followed by cereals and cereal products and sweet products, with chocolate and other products featuring prominently. For inorganic arsenic, we used a specific analytical method based on arsenic speciation in order to being able to analytically distinguish the most toxic inorganic arsenic fraction. So inorganic arsenic was measured quantitatively by HPLC ICP-MS, and this was probably the first total diet study which provided species-specific data for inorganic arsenic. And this is published. You will find the reference at the bottom. We did identify a proportion of children with relatively high exposures, and the most influential food category was cereal and cereal products, followed by water and non-alcoholic beverages and vegetables. Notably, this reflects the average exposure in Italy, but we do know that in specific areas of Italy we do have issues of geochemical anomalies where inorganic arsenic is present in the water network. Although complying the legal limits in these specific areas, water happen to be quite an important exposure source for inorganic arsenic. These are data for cadmium, and as you see, we have here a quite important proportion of especially younger age groups which are exceeding the TWI. This is a situation which happens all over Europe, and nevertheless is of concern. We have in the Italian diet cereals and cereal products contributing the most, followed by vegetables, fish and seafood, and potatoes and tubers. These were the data obtained at the time for nickel, which were considered of concern. But a couple of years after, EFSA reevaluated the health-based guidance values for both acute effects and chronic effects. As you know, besides chronic effects, there might be acute effects in subjects with nickel hypersensitivity, which is an oral syndrome for subjects with skin sensitization. So the reference values you see on the right top were changed, and the new EFSA TDI for chronic effects is 13 microgram per kilogram body weight, meaning that in the end, with the new reference value, the proportion of subjects exceeding the TDI was practically null. The most important sources for nickel exposure are cereals and cereal products, sweet products, vegetables, and also these results are published, as you see. For methyl mercury, we estimated all mercury present as methyl mercury, but this is currently being refined because, again, speciation data are being obtained by HPLC ICP-MS. So this, the data you see currently shown are a bit an overestimation of the true exposure. Still, they were able to point out that there was a proportion of women of childbearing age with relatively high exposure, and this is of course of concern. Fish, as expected, contributed the most to this exposure, and seafood only for about 10%. And we also had a proportion of children with relatively high exposures. Lead is another trace element of concern. We don't have thresholds for the adverse health effects of lead, and in this case we did consider specific age groups because the different BMDLs are identified for specific endpoints referred to specific age groups. So for children, this means covering children up to 7 years of age, where the neurotoxic effects of lead are most meaningful, and you see indeed a proportion of children with high exposure levels was relatively high exposure levels was identified. We have water and non-alcoholic beverages contributing the most, followed by cereals and cereal products, vegetables, fish, and seafood. Finally, these are the results for aflatoxin B1. This was also considered as a substance of relatively high concern based on the BMDL, and applied a margin of exposure of 10,000. Actually, substance is considered of lower health concern if the margin of exposure is more than 10,000 due to the type of effects aflatoxin B1 is performing, and we did identify a portion of the Italian population which did not met this margin of exposure. And sweet products and cereals were the most important sources. Finally, I would like to show you some results we obtained for dioxins and dioxin-like PCBs. These results were a bit unexpected in terms of the food categories contributing the most to exposure, because for dioxins and furans, we did find that cereals and cereal products actually were the most important contributor to exposure. This is rarely covered by studies performed with designs which are different from the total dye study design, but covering the entire diet allowed to actually detect these important contributions of cereal products in Italy. And the other sources are well-known sources: meat and meat products, fish, and mainly cheese. But as I said, the unexpected result was the important contribution of cereals and cereal products. A different pattern is, of course, obtained with dioxin-like PCBs, where fish is the largest contributor, followed by butter and cheese. So this is just a graphical representation of the level of detail we could obtain at the level of core food. This is for inorganic arsenic, and this is of course very useful because for the 51 core foods we were able actually to have estimates of the contribution to exposure for the different age groups and different geographical areas, and this was important for follow-up actions. And another general consideration I would like to do before going to the conclusion is the prioritization of the different substances, and specifically here we talk about the contaminants. We could prioritize them based on the risk characterization that was performed. The table you see captured the 10 top substances which were considered for follow-up investigations and actions. This list has been updated subsequently because there were changes. For instance, we have seen that the health-based guidance values for nickel did change, and this led nickel to disappear in this list. And on the other hand, EFSA reevaluated dioxins and dioxin-like PCBs, and this group of substances became one of the top priorities based on the new health-based guidance values identified by EFSA. So my point is that TDS are definitely important tools for prioritization of substances. They are tackled by the same approach, with the same design, and they allow refined risk assessment to be performed. So going to the conclusions, the Italian TDS addressed 65 substances covering both nutrients and contaminants. Dietary intake was estimated for the whole population, for selected population groups. For contaminants, the mean exposure was compared with the HBGVs. For overall exposure was low or medium-low range when compared to other total dye studies. Intake of nutrients showed in most cases also adequate supply and absence of excess exposure, with a few exceptions which were subject to follow-up studies. Overall, the national TDS highlighted the quality of the Italian total diet for both the nutrients and the contaminants investigated. However, as we have seen, some substances deserve attention, as intake in critical population groups might lead to health risks, and a prioritization has been proposed for follow-up and dedicated studies. And acknowledging the contribution of the Italian Ministry of Health, which funded a large part of the study, and also the collaboration with colleagues of the Council of Agriculture for Food Consumption Data. I thank you very much for your attention, and I'll be happy to take any question if there is time to do that.